Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a 3D isometric projection of a solid in which the front view face, the top view face and the right hand side view face of the solid, they have been appropriately integrated into a single 3D isometric projection over here. So now using the information available with us into this 3D isometric projection, we are required to obtain the front view orthographic projections, the top view orthographic projections and the right hand side view orthographic projections of the solid. So in order to obtain the orthographic projections of the solid, we are required to evaluate the dimensions of the front view face, the top view face and the right hand side view face corresponding to the solid. Now when we observe the solid from the front view orientation, we observe that the width of the solid happens to be equal to 35 millimeter, while the height of the solid it is equal to 38 millimeter. So the front view face of the solid will be having the dimensions 35 millimeter by 38 millimeter. Now when we look at the solid from the top, so we observe that the width of the solid will be equal to 35 millimeter, while the depth of the solid it is equal to 25 millimeter. So the top view face of the solid will be having the dimensions 35 millimeter by 25 millimeter. Whereas when we are going to observe the solid from the right hand side view orientation, we find that the depth of the solid it is equal to 25 millimeter, while the height of the solid it is equal to 38 millimeter. So the side view face of the solid will be having the dimensions 25 millimeter by 38 millimeter. So with this information, we are required to evaluate the orthographic projections corresponding to this engineering object. So now here we have drawn the XY reference line, the X1, Y1 reference line, and we have also marked a transfer line which is going to originate from the intersection point of the XY reference line and the X1, Y1 reference line, and this transfer line happens to be inclined with respect to the XY reference line at an angle of 45 degree, and this transfer line will be used to transfer the distances alongside the depth of the solid into the top view projections onto the right hand side view projections over here. Now since we are going to obtain the orthographic projections of the solid into the first angle projections, so the front view projections corresponding to the solid will be obtained above the XY reference line. The top view projections of the solid will be obtained below the XY reference line, and while the right hand side view projections corresponding to the solid will be obtained on left hand side of the front view projections over here. Now let us proceed to evaluate the front view orthographic projections of the solid. So we know that the width of the solid happens to be equal to 35 millimeter. So we have marked this width of the solid equal to 35 millimeter into the front view projections, and here we have drawn two vertical projector lines which are separated by the distance equal to 35 millimeter into the front view projection view, and these two vertical projector lines we have extended them into the top view projections as well, because into the top view projections also we are going to require the width of the solid equal to 35 millimeter. Now when we observe the solid from the front side, we observe that the height of the solid happens to be equal to 38 millimeter. So we have marked this height of the solid equal to 38 millimeter into the front view projections by drawing a horizontal projector line at a distance of 38 millimeter from the XY reference line, and this horizontal projector line we have extended into the right hand side view projection view over here, because into the right hand side view projections also we are going to require height of the solid equal to 38 millimeter over here. Now when we look at the solid from the top, so the width of the solid we have obtained as 35 millimeter, while the depth of the solid we know it happens to be equal to 25 millimeter. So now we have marked this depth of the solid is equal to 25 millimeter into the top view projections by drawing two horizontal projector lines into the top view projections which are separated by the distance is equal to 25 millimeter. And these two horizontal projector lines we have appropriately transferred into the right hand side view projections as well, so that into the right hand side view projection view we are able to obtain depth of the solid is equal to 25 millimeter and the height of the solid it is equal to 38 millimeter. So this way we have been able to obtain the front view face, the top view face and the right hand side view face into the orthographic projection view over here. Now in order to obtain the orthographic front view projections of the solid, now we can divide this solid into multiple elements over here. Now we can divide the solid into four elements over here. There is one vertical wave which happens to be parallel to the front face of the solid, and this vertical wave happens to lie towards the rear face of the solid over here. Then the element number 2, it happens to be a vertical wave which is perpendicular to the front face of the solid. Again there is a vertical wave which is element number 3 which happens to be perpendicular to the front face of the solid. Then we have got this element number 4 which is again a vertical wave perpendicular to the front face of the solid. So in between here we have got a rectangular groove number 1 which is located on the left side of element number 3, and there is a vertical groove number 2 over here which is located on the right side of the element number 3 over here. So this way, once we divide the solid into multiple elements over here, now we observe that the width of the solid happens to be equal to 35 millimeter, while the width of different elements they have been provided to us. So the width of element number 2 which is a vertical wave perpendicular to the front face of the solid, so this width of element number 2 happens to be 6 millimeter. The width of this rectangular groove onto the left hand side of element number 3 over here, it is equal to 5 millimeter. Then we have got the width of the element number 3 which is again a vertical wave perpendicular to the front face of the solid. So this width has been provided to us as 13 millimeter. Then we have got width of this rectangular groove which happens to lie onto right hand side of this element number 3 over here. It is equal to 5 millimeter. And finally we have got the width of this vertical wave which is lying towards the right hand side face of the solid is equal to 6 millimeter. This way we have been able to evaluate the width corresponding to the different elements of this engineering object. So now we have marked the width of different elements into the front view projections over here, and 4 vertical projector lines we have been able to obtain into the front view projections, and these 4 vertical projector lines we have appropriately transferred or extended into the top view projections as well. Now when we look at the solid from the front side, we observe that into this element number 3 which happens to be a vertical wave which is perpendicular to the front face of the solid, here we have got an inclined surface in between, and there are two vertical faces which are available. One vertical face is available onto the bottom side of this vertical wave, and another vertical surface is available towards the top face of the solid over here. So now we have been provided with the information that the height of the vertical face which is available with us into the element number 3, it happens to be equal to 6 millimeter. So we have marked a distance of 6 millimeter from the bottom of the solid into the front view projections using a horizontal projector line, and we have extended this horizontal projector line into the right hand side view projections over here. Similarly, corresponding to this rectangular vertical face which is lying at the top surface of the element number 3 over here, we have been provided with the information that at a distance of 26 millimeter from the ground, we are going to obtain the lower portion of this vertical web over here. So now we have marked a distance of 26 millimeter from the ground, and at a distance of 26 millimeter from the ground, we have marked a horizontal projector line into the front view projections, and we have extended this horizontal projector line into the right hand side view projections over here. So now we can join different segments of this object which are visible to the observer over here. So when the observer is going to look at the solid from the front side, so this rectangular block will be visible as an outline to the observer over here. We can check. So this portion of the solid, it will be visible to the observer from the front side over here. So this way a rectangular projection will be obtained. Now we know that this is left side vertical web perpendicular to the front face which will be visible to the observer, and it is having the dimensions height is equal to 38 millimeter and width is equal to 6 millimeter. So this is our element number 2. So corresponding to the front face of the element number 2, the true shape projections will be obtained into the front view projections over here, and corresponding to this rectangular slot which is available onto the left hand side of element number 3. So again, true shape projections corresponding to this rectangular slot measuring 38 millimeter height and 5 millimeter width will be visible to the observer over here. Similarly, corresponding to this rectangular slot which is available on right hand side of the element number 2. So again we are able to obtain true shape projections corresponding to this rectangular slot visible in the front view projections over here, and here corresponding to this element number 4, that is a vertical wave perpendicular to the front face of the solid. So this rectangular surface will be projected as true shape into the front view projection. So corresponding to element number 4, we are going to obtain rectangular projections measuring 38 millimeter height and 6 millimeter width into the front view projections over here. Now we are left with this vertical wave which is our element number 3. So corresponding to this vertical wave, we know that there is a flat vertical portion which is lying towards the base of the solid at a height of 6 millimeter. So this surface will be visible to the observer from the front view orientation as a true shape projection over here. Similarly, corresponding to this vertical rectangular surface which is lying at the top surface of the element number 3, we will be able to obtain true shape rectangular projections into the front view projections over here. Whereas corresponding to this inclined surface of the element number 3, we will not be able to observe true shape projections into the front view projections. Why? Because this surface happens to be inclined with respect to the vertical plane. So onto the vertical plane into the front view projections, we will be able to obtain apparent shape rectangular projections corresponding to this inclined surface of the element number 3 over here. So this way we have been able to obtain the front view orthographic projections of the solid. Now when we observe the solid from the top, so now we can check this vertical web which is lying at the rear side of the solid. So this vertical web, it is parallel to the front face of the solid. And another information we have got, the depth of this web, it happens to be equal to 6 millimeter. How did we obtain this dimension as 6 millimeter? Because we know that this distance of the front face of the top surface of the element number 3 over here, it happens to be 19 millimeter from the rear face of the solid. So this dimension happens to be 6 millimeter. This dimension, that is the dimension of the slot, it happens to be 7 millimeter. So out of 19 millimeter, this remaining portion, it is the depth of this vertical web which happens to lie parallel to the front face of the solid. And this vertical web has been obtained onto the rear face of the solid over here. So now from the rear face of the solid, we have marked a distance of 6 millimeter. Similarly, corresponding to the slot, we have marked a distance of 7 millimeter. Corresponding to this distance, that is ahead of the slot and up to this extreme point, we have marked a distance of 6 millimeter over here. So now corresponding to these three distances, we have marked three horizontal projector lines into the top view projections, and these three horizontal projector lines, they have been appropriately transferred into the right hand side view projections over here. Now once we are going to look at the solid from the top, so we observe that this face of the solid will be visible to the observer as an edge view. Similarly, this face of the solid measuring 13 millimeter depth over here, so this will also be visible to the observer. And then you have the width of this particular element number 2, which is a vertical web perpendicular to the front face of the solid. This happens to be 6 millimeter. So then we have got this width as 6 millimeter and depth of the slot, it is equal to 7 millimeter. We have been provided with the depth of the slot as 7 millimeter. So that now we can check the depth of the rear side element number 1 vertical web, which happens to be parallel to the front face of the solid. It is equal to 6 millimeter. So this way, this distance will be equal to 25 millimeter. We can check. This is up to 19. This will be true length, but this distance will be the apparent length or the apparent shape over here. So this rectangular projection will be obtained as, or it will be viewed as, apparent shape projections into the top view projections over here. So we can check this inclined surface has been projected as an apparent shape projections into the top view projections. We can check it's a very big surface. Corresponding to this relatively bigger inclined surface, we have been able to obtain a foreshortened apparent shape rectangular projections into the top view projections over here. Whereas this T-shaped projection, which we are able to obtain into the top view projections, these projections, they are true shape projections projected onto the horizontal plane. So this way we have been able to obtain top view projections corresponding to this engineering object over here. Next, when we are going to observe the solid from the right hand side view, so we observe that the rear surface of the solid will be projected as an edge view into the right hand side view projections. Then the base of the solid will be visible to the observer. Another thing, corresponding to this element number 4 over here, we are able to observe true shape projections corresponding to this vertical web, which is perpendicular to the front face of the solid. So this vertical web will be projected as a true shape into the right hand side view projections over here. Similarly, corresponding to this slot and this surface over here, because this surface, it is also parallel to the profile plane. So corresponding to this surface, we will be able to visualize true shape projections of this surface onto the profile plane. But there is a problem with this surface, because the whole of this surface is not visible to the observer. This portion of the surface, which is lying on the other side of the slot, that is up to a distance of 7 millimeter from this face. So this surface is not visible to the observer. So we have to draw a dotted line projections over here corresponding to a distance of 6 millimeter from the rear face of the solid. So now this portion of the solid we have marked as a dotted line projections corresponding to this rectangular slot which is available on the right hand side of the element number 2 over here. So up to this distance we have marked this dotted line, and then we can see that this is a total surface which has been projected as a true shape projection into the profile view projections over here. But this surface will not be visible to the observer. So that is why we have marked a dotted line projections into the right hand side view projections corresponding to this vertical surface which is not visible to the observer over here. And now we can see there is an inclined surface towards the front side of the solid. We have been able to obtain the inclined edge view projections corresponding to this inclined surface of vertical web, that is element number 3, which is perpendicular to the front face of the solid over here. So this way we have been able to obtain the orthographic front view projections, the orthographic top view projections, and the orthographic right hand side view projections corresponding to this engineering object, for which we had been provided with the 3D isometric projection over here. So this is all for today. So we will be continuing with further discussion regarding few more illustrative cases of orthographic projections of the solids in the coming classes. So thank you very much. Thanks a lot.